Find the Jacobian matrix and all critical points of this system. So, by the way, this is an example of autonomous system. Let me call it the first function f x y and the second function z g x y. So let's compute the Jacobian matrix J. df over dx, df over dy, dg over dx, dg over dy. So we first need to compute that. That's for the first part. For second part, you just need to assume this one equals 0, this one equal to 0, phi x and y. So let's do the first part. Jacobian matrix is this one, df over dx, which is minus 3 df over dy, 2 times y, dg over dx, 2 times x, dg over dy, minus 2 times y. So this question is easy. Second one, find all critical points. The critical points are the points so that the derivative are 0. So equal to 0, equal to 0. So this is equivalent to minus 3x plus y squared plus 2 equal to 0. X minus y times x plus y equal to 0. I will have two cases right here. This one equal to 0 or this one equal to 0. Case 1. X minus y equal to 0, which is equivalent to x equal to y. So you can replace x equal to y to the first equation. You have minus 3y plus y squared plus 2 equal to 0. Y squared minus 3y plus 2 is 0. So you can compute delta in general ax squared bx c equals 0. You compute delta b squared minus 4ac. And in this case, I can guess the solution immediately. Y squared, you can factor that like this. We want the form y minus a, or I don't want to use the same notation as this a, but it's not the same as this ap. Just y minus a is y minus b is 0. We want a and b in such a way that a times b give us 2 and a plus b give us 3. So one of them will be 1, the other one is 2. So this one gives us y equal to 1 or y equal to 2. So in this case, you have critical points 1, 1, 2, 2. Let's do the second case. Second case, x plus y is 0. X equal to minus y. So I will plug that in the first equation. X equal to minus y. So minus 3x minus 3x is minus 3 minus y, 3y, 3y, y squared, 2, 0. This one equivalent to y plus 1 times y plus 2 equal to 0. Y equal to minus 1 or y equal to minus 2. So because x equal to minus y, so minus 1 plus 1. Second case, x equal to minus y, which is 2. So we have two critical points in this case, 1 minus 1 and 2 minus 2. So we have in total 4 critical points. All critical points are 1 1 2 2 1 minus 1 2 minus 2. So we answers all the question we have. We found the Jacobian matrix, which is this matrix, and we found all critical points.